To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today I am going to discuss with you all a GCE O-level examination paper, that is the year 2020 paper with you all. So as you all might have seen the paper before, you all know this is actually conducted by the Department of Examination Sri Lanka. I have actually put the top part of the paper. This is a model that is created by us. So we have just to introduce you all to the instructions. I have put this part first. So here you can see the label is given to you. The all rights are reserved by the Department of Examination Sri Lanka. Then you should be familiar with this particular box that gives the number 34. That is the number relevant to science. Science subject is number 34 and E says it's the English medium and 1 for paper 1. So that is the top part. Then here the name is given General Certificate of Education, Ordinary Level Examination, year 2020. Again here they say Science 1 and also the duration 1 hour. So you all have to complete the paper within 1 hour. I'm sure you all know there are 40 questions, 40 MCQ questions. All the questions should be answered within that given 1 hour. So if we look at the instructions first. Here you can see answer all questions. So like I told you all, there are 40 questions, 40 MCQ questions, each question containing 4 answers. You have to read the question, select the answer, and you have to mark the answer on the answer sheet. All this has to be done within 1 hour. If you don't do even one question, if you leave out one question, if you don't mark the answer for one question, then you will be losing marks. So you have to answer all 40 questions. Answer all questions. Then the second instruction. In each of the questions 1 to 40, pick one of the alternatives 1, 2, 3, 4, which you consider is correct or most appropriate. Here you all have to understand, students, they say consider is correct or most appropriate. Now say there are questions where you get a direct answer. Maybe a calculation, a name of a scientist, name of an organism. There it will be a direct answer. Only one correct answer will be there. But there are instances where you can have 2 answers which are correct, but out of the 2, one would be more suitable for that particular question. Then you have to select the most appropriate answer. That is why they say correct or most appropriate answer. So you read the question carefully, you select the answer from the answers 1, 2, 3 or 4. And then you mark a cross on the number corresponding to your choice in the answer sheet provided. So you have to mark the answer in the answer sheet that is provided to you all. So I'll go to the next slide where I have an answer sheet for you all. Now here you can see, students, this is again a format of the answer sheet that is given to you all. Here also they have said GCE O-level MCQ answer sheet. Here you have to write the subject. You have to either say subject science, or sometimes they ask you to write the subject number also. Then you have to write it as 34 as well. Then you have to write the index number here. And when you're marking the answer, students, let's say for the first question, your answer is 2. So you have to mark a cross on 2. And for your second question, the answer you select is number 4. Then you mark a cross on number 4. Then third question, number 1, we'll say answer is the first one. Then you will have to put a cross here. Now this is how you have to mark. Now when you all are marking, you have to make sure you mark only one answer for one question. Let's say you mark your answers in your question paper, and if you are transferring the answers to the answer sheet. Now by mistake, let's say for the fourth question, if you mark this and this, then you will not get marks because this looks as if you have marked 2 answers. That is incorrect. So that is incorrect. Do not do that. Let's say another instance. For the 7th question, you mark 1 first. Then you realize that the answer has to be 3. Then if you cut this like that and if you mark 3 also, again, it's not correct. You have to mark the answers correctly. 1 answer for 1 question and it has to be neatly done. You cannot use Tipex. Don't go to erase it and tear the answer sheet because you will be getting 1 answer paper. So you have to be careful when you mark the answers. So if you are not sure about an answer for a particular question, what you can do is either you can mark it with a pencil and later when you are checking the question, that is again within the first 1 hour that is allocated for you all, when you are checking the questions and answers again, you can mark it with a pen. So you have to make sure that you mark the answers in a very neat manner. So this is also incorrect. Do not do this. Only 1 answer for 1 question and make sure that you answer all 40 questions. Is that okay, students? No 2 answers. Don't leave it blank and also do it neatly. So that is how you are supposed to mark the answers. And also, if you turn this sheet also, at the back of the answer sheet, there will be more instructions. You have to read that as well and you have to mark the answers according to it. Is that clear? So read the instructions given in your question paper as well as the instructions given on this paper also. So with that, I'll move on to the next one. Now here, this is again a model of the paper. So I was reading the instructions for you all. I read the 3rd one, mark a cross on the number corresponding to your choice in the answer sheet provided. I explained that. And also further instructions are given on the back of the answer sheet. Follow them carefully. So that also I told you all. So as I told you, this is again a format of the question paper. This is the O-Level 2020 examination paper. Now if you look at the questions here. Now you can see the first question, the fundamental structural and functional unit of life is you have the 4 answers, cell, tissue, organ, system. So out of this, you select the most appropriate answer and you mark it on the answer sheet. Now if you look at the questions, you can see here students, now this is related to a biology lesson. Then if you look at the second one, what is the pair of subatomic particles which attract each other? It is a chemistry related question. Then the third one, the unit of momentum. So that is a physics related question. So like that, this particular paper 1, that is the MCQ type question, includes questions from your grade 10 and 11 syllabus and from various lessons. Now, when you answer the paper 2, you will see a part of a question is related to one particular topic. But here, each question is from a different topic. So, basically, it covers almost the whole syllabus, all the lessons given in your syllabus. So, you should be able to answer all of them. Now, here also, if you look at it, there are more questions given here. Some have diagrams, some have molecules like that. Then you have all the questions here and the answers. Then you can see a graph is given to you, a large introduction where you need to use this introduction to answer both question 9 and 10 with the relevant diagram given there. Again, here also you can see with the introduction, then another part of a graph. Like that, you can see different formats of questions. Now, here also you have all the questions again here with a diagram. The diagram itself becomes the answer. So, like that, different formats of the question. Here also you can see from 23 to 31, there are so many different types of questions from different lessons. And again, here also you have the questions, like I said, again with the diagram, the graphs being the answers, then equations, then you have statements from which you need to select correct and wrong, false and true. Like that, you have so many various types of questions. And finally, you have up to the 40th question. So, question number 1 to 40, all the questions have 4 answers. Out of the 4, you need to select the correct or most appropriate answer. Is that okay, students? So before I discuss the answers with you all, it's good if you all can answer the question first. You can either get a printed copy of this paper. If you have one, you can answer using that, or else you can download it from the website of the Department of Examinations, or else there is a link given under this video. In that also, through that also, you can download this paper. So once you do that, answer the questions by yourself first, and then you all can listen to my discussion. So with that introduction, students, I will now discuss the questions one by one with you all. So this is the first question. Now here I have put the question in a way that it's easy for me to discuss the questions and answers with you all. If we look at the first one, the fundamental, structural and functional unit of life is the answers. First one cell, second one tissue, third one organ, and fourth one system. So you all know this is related to the organizational levels and the structural and functional unit of life. To understand this, I'll move on to the next slide. Now here I have put a picture for y'all. Y'all can see initially we have the heart muscle cell. So you can remember, students, if we take the organizational levels, it is the cell first. Then when a group of cells that have the same origin are adapted to perform a particular function, what do we call them? They become the tissues. The cells together become the tissue. So here you can see from the heart muscle cells combine together and they form the heart muscle tissue, or what we call as the cardiac muscle tissue. Then when there are different tissues together, you get the organ. You can see here organ. Now this is made up of muscle tissues, nerve tissues, blood tissue. All that together gives rise to an organ. And a lot of organs together form a system. Now here you can see a blood circulatory system, the heart with the veins, arteries, all the different types of organs together relevant to that particular system makes up the system. And many systems together, you all know this becomes the system, and from there we get the organism. Now organism is made up of many systems that are made up of organs. Organs are made up of tissues. Tissues are made up of cells. So when we come to cell, you can have an organism with just one cell or many cells. So you're familiar with unicellular organisms as well. Now this particular organization, that is for, now here you can see we said organism, that is a multicellular organism. In addition to that, you can have a unicellular organism. Say Chlamydomonas, Paramecium, all these are bacteria, they are all unicellular organisms. Now these unicellular organisms also carry out all the functions. They do respiration, they do reproduction, excretion, all that is done by a unicellular organism. Same thing, a multicellular organism also. And within the cell, you all know there are organelles that carry out many functions. So because of all that, I'm sure you all know that cell is the basic structural and functional unit of life. And I'm sure you can remember Robert Hooke was the scientist who initially discovered cell. And there are the three scientists, Schleiden, Schwann and Rudolf Virchow. The three of them together proposed the cell theory. And in the cell theory also, the first point is the structural and functional unit of life or living organisms is the cell. So I'm sure you have a clear understanding about that. Then if I move on to the question again, the fundamental structural and functional unit of life is the cell. You can answer that easily. So cells together form tissues, tissues together forms the organ, and organs combine and form the system. So that is the organizational level. Is that clear, student? So then we'll move on to the second one. So here, the second question, what is the pair of subatomic particles which attract each other? If you look at the answers, electrons and neutrons, second one electrons and protons, third protons and neutrons, and fourth one electrons and electrons. Now to understand this, we'll just look at the model of an atom. Now here, this is the planetary model of the atom. Can you all remember who proposed that? Ernest Rutherford. So this was actually proposed by Ernest Rutherford. He proposed the planetary model of atoms. Why? Now you can remember, students, now here in this nucleus. Now the nucleus contains both protons which are positively charged and neutrons that are neutral. And these protons and neutrons are the subatomic particles that have a mass. So because of that, all the mass is concentrated in this nucleus, and also the nucleus is positively charged. Then here you can see, now these are the electrons. They are the electrons. Now these electrons move around in orbits. So here, if you compare this with the model of a solar system, this is like the sun, the nucleus, and there are the orbits, and in the orbits you have the planets. So the electrons are like the planets. Now these electrons are negatively charged. Electrons are negatively charged. So positively charged protons are there in the nucleus. Electrons which are negatively charged, they are moving around in orbits. And there is attraction between the positively charged protons and the negatively charged electrons. Because of that attraction only, these electrons remain in their path. At the same time, you all know, now because of this attraction, there is a possibility that the electrons come closer to the nucleus and can collide with the nucleus. But that does not happen. Why? Because the electrons themselves, they are rotating on their axis. So these electrons are rotating and they are going around the nucleus. So because of that, they remain in their orbit. At the same time, there is attraction between the nucleus and the electrons. So in the nucleus also, it is the protons and the electrons. So you all know what the attraction is. And here again, you know, students, positively charged protons, they can repulse each other because similar charges. The same way, electrons also can repulse each other because they are all negative charges. That is why when atoms undergo bonding, you all can remember the covalent compounds, the electrons arrange themselves so that there is less repulsion between them. That's why we have different shapes. You can remember, for example, water molecule has a V shape with the lone pairs and the two bond pairs. That is because of the repulsion between electrons. So the subatomic particles that attract each other are protons and electrons. Positively charged protons and negatively charged electrons. Now if we look at the question, what is the pair of subatomic particles which attract each other? The pair of subatomic particles that attract each other, electrons and neutrons? No, because neutrons are neutral. They don't have a charge. Electrons and protons? Yes. Protons and neutrons? No, they are all inside the nucleus. And electrons and electrons, I told you all, they do repulse each other because they are negatively charged. So it is electrons and protons. Is that clear, student? So then we'll move to the third question. Now here, the unit of momentum is. Now what is momentum? Momentum, you all know, is the difficulty in stopping a moving object. So let's say if there is a sphere that has a mass of 10 kilograms, it is moving with a velocity of 2 meters per second towards this direction, then the difficulty of stopping this moving object is what we call as momentum, and that is defined as momentum P is equal to mass into velocity. P is momentum, that is equal to mass into velocity. So if we substitute the values, now mass will be in kilograms and velocity will be in meters per second. So kilogram into meters per second will give you the unit for momentum. So here of course 10 kilogram into 2 meters per second, it will be 20 kilogram per meters per second. That is the momentum of this particular object. So in the question of course they have asked for the unit of momentum is kilogram meters per second. First answer, that is correct. Second one, kilogram meters per second squared, not correct. Kilogram meter minus 1, second minus 1, no. And kilogram meter minus 2 and second minus 2, that is also not correct. So here of course we have the first answer, that is momentum. What is this one? Kilogram meter second minus 2. Meters per second squared is acceleration. Mass into acceleration, what is that? That is weight. You all can remember that now. Weight equals mg. So that is equal to kilogram meter second minus 2. That is weight. But these two, we don't use these units in our syllabus. So first one is the unit of momentum, kilogram meter second minus 1. And the second unit, it is similar to the newtons, that is weight. So here if you write the final answer, this is also equal to newton, that is similar to weight. So out of that, the correct answer is the first one. With that, the fourth question, question number 4. The figures A, B and C below indicate 3 types of muscle tissues. So they have already said it's muscle tissues. Now you all know the function of muscle tissues. They are there for the movement as well as locomotion. Now while I am talking to you all, when I am moving my hand, I need the muscles to function. At the same time, within my body, the heart is beating, I am respiring. For all those also, we need the muscles. For digestion, the muscles are required. If I need to walk, locomotion, for that also we need muscles. So based on that, there are 3 types of muscles depending on their function as well as the structure. You are familiar with the 3 muscles. Here they have given the diagrams. Now look at the diagrams. First one, you can see these are spindle-shaped cells. You all know what spindle shape is. Now when you look at the shape of this one, the middle part is broad and towards the end it is a tapering end. So here you all can see, students, in each of the cell there is a nucleus. Now that is a nucleus you can see. So a spindle-shaped cell with one nucleus, so it's a uninucleate cell, and you don't see any cross striations. So it is a smooth muscle. So you can identify this as smooth muscles. The spindle shape, one nucleus, no cross striation. So that is a smooth muscle that is shown as figure A. Then if you look at figure B, can you all see? These are long cylindrical structures. Now here you can see the long cylindrical structures, and also here you can see there are many nuclei. Now those disc-like structures are the nucleus. So this is actually a multinucleate fiber. And there you can see the cross striations also. So what is this? This is the skeletal muscle. So this is the smooth muscle. Then you have identified this as the skeletal muscle. Skeletal muscle. Then here you can see these are short branch cells. And here you can see there is one nucleus. Here you can see there is one nucleus. And if you look closely, you will see the intercalated disc or the intercalary disc. So this you all can see is a cardiac muscle tissue. Cardiac muscle. So first one is smooth muscle, then the skeletal muscle and cardiac muscle. Now from the shape also you all can identify similarities and differences. I'm sure you can remember them. Both smooth and cardiac, they have one nucleus, whereas skeletal, it is multinucleated. Whereas B and C, that is skeletal muscle and cardiac muscle, they have a cross striations are there. So that is a similarity. Then here, of course, this is a spindle-shaped cell, a unique feature. This is an unbranched, cylindrical, long cylinder-like structure. And here, of course, this is a branched cells with intercalated disc. So like that, they have similarities as well as unique properties. And also you all know both smooth and cardiac muscles, they are actually involuntarily controlled, whereas the skeletal muscles are voluntarily controlled. And cardiac muscles never get fatigued. Smooth muscles don't get fatigued easily, whereas the skeletal muscle, they do get fatigued. So you know the similarities and differences, and you know to identify the three types of tissues: the smooth muscle, skeletal muscle and the cardiac muscle. So if we look at the question, A, B and C above respectively are. So that is what you need to find, you need to identify them. Smooth muscle, cardiac and skeletal muscle, no. Skeletal muscle, smooth muscle and cardiac muscle tissue, no. Smooth muscle, skeletal muscle and cardiac muscle tissues, correct. Then fourth one, cardiac muscle, skeletal muscle and smooth muscle tissue, that is also incorrect. So the third answer is the correct one. Is that okay, student? So then we'll move on to the fifth question. Question number 5. Which of the following is the molecule with the highest number of covalent bonds? So here you need to find the highest number of covalent bonds. So you all know, students, when atoms share electrons between them, you get the covalent bond, sharing of electrons. And those molecules can be actually represented in 3 ways. You can remember the dot cross diagram, then the Lewis dot diagram and also the Lewis structure. So here I will use the Lewis structure to represent these 4 compounds. Now O2, it is a diatomic molecule. You all can remember there is a double bond between the 2 oxygen atoms, and also there are 2 lone pairs on each of the oxygen atom. Now how many covalent bonds are there? There are only 2 covalent bonds there. Then if you take nitrogen, between 2 nitrogen atoms there is a triple bond and a lone pair on both the nitrogen atoms. A lone pair each on both the nitrogen atoms. So how many bonds are there? Covalent bonds. There are 3 covalent bonds. How about ammonia? Ammonia, you have nitrogen in the middle, 3 hydrogen atoms with an NH single bond and a lone pair of electrons on nitrogen. So how many bonds are there? There are 3 covalent bonds. Here there are 3 covalent bonds. Then the last one we have is carbon dioxide. Carbon dioxide, you all know, it has carbon-oxygen double bonds. 2 carbon-oxygen double bonds should satisfy the valency of carbon. At the same time, there are 2 lone pair of electrons on oxygen. So that is carbon dioxide. How many bonds are there? Now a double bond here, a double bond there. So there are 4 covalent bonds. Now if you look at all the molecules, all the Lewis structures, oxygen has 2 covalent bonds, nitrogen 3 covalent bonds, ammonia again 3 and carbon dioxide 4 covalent bonds. So the question is to find the highest number of covalent bonds. O2, N2, ammonia and CO2. Oxygen, nitrogen gas, ammonia gas and carbon dioxide gas. So out of that, carbon dioxide has the highest number of covalent bonds. I'm sure you all can understand that. So with that, the next question. Question number 6. Look at the question. Now here, heat is transmitted from the sun to earth by radiation, conduction, convection, radiation and convection. So you all are familiar with the 3 ways in which heat is transferred from one object to the other or one place to the other. We will try to go through these 3 methods initially. So here I have given the examples. Now you can see. Now here there is a hot cup of tea and inside that you have a metal spoon that is a solid. It is a solid. So the spoon is a solid. Now when the spoon is inside a hot cup of tea, after some time when you touch the end of the spoon, you can feel that it is also hot. So how did the heat transfer from the tea and also part of the spoon that is inside the tea to the end of the handle of the spoon? That is by conduction. This process that is happening in solids that transfers heat is known as conduction. How does this happen? You can remember, students, when you have a solid material, now there are the particles, the constituent particles. Usually you can take any metal as an example. When you provide heat to one end of it, these particles, the constituent particles absorb heat. Heat energy, that is thermal energy, is converted to kinetic energy. Then due to the kinetic energy, these particles start to vibrate faster. And due to this vibration, they transfer or make the other particles also to vibrate. When like that particles start vibrating, they transfer the kinetic energy. By transferring the kinetic energy, they transfer heat. So transfer of heat due to the vibration of particles in a solid is what we call as conduction. So in solids, it is conduction. Then, if you take the second one, this is in a liquid. Now you are familiar with this also. We put a small piece of potassium permanganate, a chunk of corn is there. Then you have water inside the beaker. There is water. You put a small chunk of condensed and you provide heat to that particular space, part of the beaker. So when water gets heated up, what you see is the movement of these colored particles. Why does that happen? Now water is a liquid. In a liquid, when the particles at the bottom get hot, the hot particles move upwards. And this movement of hot particles is known as convection current. And this process where the particles, the hot particles are moving in this manner is known as convection. So the hot particles move up, cool particles move down, then heat will be transferred within the liquid. Same thing happens in gases also. So in liquids and gases, it is convection. In solids, it's conduction. Then you can see the last diagram here. Can you all see this diagram? So here what is happening? The fire is here, but when you hold the hand above it, or even if you are onto the side and you hold the hands, you still get the heat radiation. Now here of course, if it is towards the top, it is convection. Here also it is convection. Convection, because there is air there. From here to the hot particles, the hot air move up and you get the heat. But if you hold the hand towards the side, then what happens? So this is, like I said, convection happening in air. But at the same time, now if you have the sun here and you have the earth there, and from the sun to the earth. Now here of course there is space. Here it is the earth, this is the sun, and between the sun and the earth there is space. Now from there to here we get the radiation. In what form? This is electromagnetic radiation. Electromagnetic radiation, or in the radiation, or in the form of electromagnetic waves. Now you can call it electromagnetic radiation based on the process, or the waves that come from the sun to the earth are electromagnetic waves. You are familiar with them. They have a constant speed of 3 into 10 to the power of 8 meters per second. They can travel through space or vacuum. They don't need a medium for propagation. So those are the electromagnetic waves. So the process by which the heat is transferred from the sun to the earth through space is what we call as radiation. So this is through space, that is radiation. Radiation. Is that clear, students? So 3 methods by which heat is transferred: in solids, conduction, liquids and gases, convection, and through space, it is radiation. I have revised all the processes also. Now if we answer the question, heat is transmitted from the sun to the earth by radiation. Conduction, you need the solid. Convection, it has to be either liquid or gas. Radiation and convection, that is also incorrect, because from the sun to the earth, we normally take it as radiation, because directly the electromagnetic rays come and fall onto the earth's surface. Is that clear, student? So the correct answer is radiation. I'm sure you can understand that. With that, the next question. Question number 7. As was extracted by a student from an environmental pyramid, that ecosystem has 1 producer, 8 primary consumers and 23 secondary consumers. The student has extracted this information from a upright number pyramid, inverted number pyramid, upright biomass pyramid, inverted biomass pyramid. So this is related to pyramids of the environment. So before I answer the question, we'll have a look at the different types of pyramids. Now you're familiar with these. So here, students, you all can see the first diagram. Now this one is an upright number pyramid. Normally, if you take the environment, the number of organisms that belong to each trophic level. So here you can see the first trophic level is the producers, for example, plants. So in a normal terrestrial environment, you have a lot of producers. The number is given to you 1000. Then you can see the cricket is a primary consumer. There are only 200 crickets. And the cockle is a bird that is a secondary consumer. Only 30 are there in that particular environment. Then tertiary consumer is hawk, only 3. So this type of pyramid that includes the number of each type of trophic level. The producer, primary consumer, secondary consumer and the tertiary consumer is known as a number pyramid. And here also you can see the shape is the normal pyramid shape. That is why it is known as an upright number pyramid. When you have more producers at the bottom level, and as you go up, the number of organisms in each trophic level decreases. So you get the upright pyramid. But there are instances again in the terrestrial environment where you get an inverted number pyramid. Now here you can see the coconut tree is a producer. A large coconut tree, but one coconut tree. In one coconut tree, you can have coconut beetles. You can have 8 of them. Because those are tiny, all 8 can live on one coconut tree. Then there you can see the secondary consumer is the insect parasite. So there can be many parasites living on just one insect. So there you can see there are 23 parasites. So the producer, that is the first trophic level, only one organism, one coconut tree. Second trophic level, 8. The number is 8. and the third trophic level 23. So here you can see the shape is inverted. Now this is a shape like that, inverted pyramid, whereas we had this normal shape here. So upright pyramid, that is an inverted number pyramid. Both are related to number of organisms. Then, if you look at the third type here, you can see this is a biomass pyramid. What is the biomass? The amount of organic matter present in a particular environment. Normally we consider the dry mass of an organism and it is taken as kilogram per meter squared per year. So that is in a square area how much of kilograms of biomass is there. Now here also you can see if you take the producers, those are the plants, the biomass is 1200. Then on that you have the primary consumers, the herbivores, 2600, it's reducing. Then in the third level, third trophic level, that is the secondary consumers which are carnivores, you have only 195. And tertiary consumers like hawk and all that, you have only 20. As you go up, you can see the biomass decreasing. So here again, this is a biomass pyramid and it is also an upright pyramid. Normally, it is an upright pyramid. That is again in a terrestrial environment. But in an aquatic ecosystem, an aquatic environment, here you can see usually the planktons are the producers. Their biomass is less. Even though they are in high number, their biomass is less. Compare that with the primary consumer, a small fish. Small fish is larger in size, so the biomass is greater. Then primary consumer, the biomass is higher. If you take the secondary consumer, a medium size or somewhat large fish, that also has a greater biomass, the secondary consumer. But if you take the last one, like a shark or any large fish, which consumes this secondary consumer, their biomass, that is the tertiary consumer's biomass, is very high. So, in an aquatic ecosystem, you will get an inverted biomass pyramid. That is an instance like this. Is that okay, students? So, these are the 4 types of pyramids. There are actually 3 different categories of pyramids. You all know the number pyramid, biomass pyramid and energy pyramid. Here, of course, we are discussing the number pyramid and the biomass pyramid. So, I have explained the normal formats or the types of pyramids and the number and biomass that you get in ecosystem. Now, if we go back to the question. If we go back to the question, you can see there are 8 primary, before that we have 1 producer, 8 primary consumer and 23 secondary consumer. And it is the number that is given to us, not the mass. They have said 1 producer, 8 primary consumer and 23 secondary consumer. So, where can you fit that? Now, you can see here 1 producer, 8 primary consumers and 23 secondary consumers. So, it has to be an inverted pyramid and also it is a number pyramid. So, from that only you can get this type of information. And then to answer the question, as was extracted by a student from an environmental pyramid, that ecosystem has 1 producer, 8 primary consumers and 23 secondary consumers. The student has extracted this information from a upright number pyramid, inverted number pyramid, upright biomass pyramid and inverted biomass pyramid. It is from an inverted number pyramid. So, I am sure you all can understand that. So, with that students, I'll move on to the next question. That is question number 8. Here is shown the displacement time graph of the motion of an object. So they have given you the displacement time graph. So you can see on the y-axis you have displacement in meters and the x-axis has time in seconds. The x-axis is marked as 0, t1 and t2. During the time intervals from 0 to t1 and t1 to t2, the nature of the motion of the object respectively is. So they want you to analyze these two parts, the part of the motion. So 0 to t1, can you see here students? It's a straight line going through the 0, 0 point. So this is a displacement time graph. Now in a displacement time graph, if you take the gradient, what do you get? Gradient of the displacement time graph. Normally gradient is what? Equals displacement over time. That will give you the velocity. Now here, since it is a straight line like that, what do you think of the velocity? It has to be uniform or constant velocity. Now this is uniform or constant velocity. That is uniform or constant velocity. So 0 to t1 should be uniform or constant velocity. Then look at t1 to t2. Now this is from 0 to t1. On the other side, if you look at t1 to t2, what do you see there? There you can see students from t1 to t2, you see something like that. The slope decreasing. Now here, if it goes like that straight, that means velocity 0. You can remember when it is a graph that is parallel to the x-axis, displacement doesn't change. That means velocity 0. So here initially there is a velocity. From there the object goes to velocity 0. So what is happening to the velocity? Velocity is decreasing. That means it is deceleration. Deceleration is also known as retardation. So from V, it goes to V equals 0. So here it is deceleration. Deceleration, why? The velocity goes from a particular value to 0. The gradient decreases. So if we look at the question given there. Now, if you look at the questions given here, question and the answers given to all students, you can see during the time intervals from 0 to t1 and t1 to t2, the nature of the motion of the object respectively is a uniform velocity and an acceleration. No, it is not acceleration. Now here students, if it was an acceleration, then of course the graph would have been like this. Now there you will have the graph where the slope goes that way. This is displacement time, then this will be acceleration. Acceleration, the gradient increases something like that. That is acceleration. You can see the difference. This is deceleration, this is acceleration. The gradient increasing. So it is not acceleration. Now if we look at the answers, second one, a uniform velocity and a retardation. Like I told you all, deceleration means retardation. Another name for deceleration is retardation, retarding, decreasing. A uniform acceleration and a retardation, no. A uniform retardation and an acceleration, that is also not correct. So we saw that this part is uniform velocity, this part is deceleration or retardation. So the answer is the second one, a uniform velocity and a retardation. Is that clear, students? So that is the answer for the 8th question. Then I'll move on to the next one. Then questions 9 and 10. So here you can see, like I told you all, 2 questions have to be answered based on one introduction and a diagram. You can see here questions 9 and 10 are based on the following information and the illustration. So this is the illustration. We'll first read the information. Production of hemoglobin is disturbed by thalassemia, an inherited disease caused by the gene mutation in a somatic chromosome. So you know the meaning of somatic cells. What is the meaning of somatic cells? Normally the cells of your body are known as somatic cells, and the gamete cells are the cells involved in reproduction. Eggs and sperms are gamete cells. Other than that, all the other cells are somatic cells. So you all know in a human body, the somatic cells contain 23 pairs of chromosomes. So the chromosomes present in this somatic cell are known as somatic chromosome, or you can remember they are the autosomal chromosomes. Out of the 23 pairs, you can remember the first 22. Those pairs are the autosomal chromosomes because they carry information that are there for the development of the body, characteristics of the body. So you're familiar with that as well. Autosomal chromosomes. Autosomal chromosome. Autosomal chromosomes, the first 20 chromosomes. The first 22. So here gene mutation in somatic chromosome, or what we call as the autosomal chromosome, gene mutation. With regard to the production of hemoglobin, naturally the dominant gene is T. So normally the capital T dominant G is related to the production of hemoglobin, while the mutant recessive gene is simple T. So the mutant gene, that is the recessive gene, is simple T. So when you have both capital T, the dominant homozygous condition, then the person is healthy. There is the normal hemoglobin production. But if the 2 genes are recessive genes, that is double recessive condition, then of course the person will have thalassemia and he or she will not have enough hemoglobin production. Due to that, the person can have anemia. The main symptom is anemia. Related to thalassemia, it is anemia. What if a person has a heterozygous gene? That is dominant capital T and recessive simple T. Capital T simple T condition is the carrier. They are healthy. The person who has capital C simple T is healthy, but they act as a carrier of thalassemia. So those are the 3 combinations. Then A, B, C and D indicate the F1 generation. So here you can see this is the illustration given. Now here they have shown the parent generation. You can see mother, capital T, simple T. So like I told you all, that is a carrier. The mother is a carrier. Heterozygous condition. The father, again capital T, simple T. So the father is also a carrier. So both of them are carriers. Then you can see the gametes from the mother, capital T and simple T. Father also capital T and simple T. And when the gametes combine and form the F1 generation, you can see here child A, offspring A is capital T and capital T from there. So this child will be healthy. Dominant homozygous condition, capital T, healthy child. Take B, capital T, simple T. That is a carrier. Capital T, simple T, heterozygous condition, it is a carrier. Child B is a carrier. Then C, simple T, capital T, but we write it as capital T, simple T. That is also a heterozygous condition, so that child is also a carrier. Then here, last one, simple T, so D is simple T. So that child D or the offspring D is a disease child. So here you can see the offspring A or the child A has capital T, so healthy. Then B and C, capital T, simple T, they are both carriers. And D, simple T, the child has thalassemia. So deceased child. Then if we look at the question 9, a thalassemia patient belonging to the F1 generation. So that is what we got from here. Who is the thalassemia patient? A is a healthy person, B and C both are healthy but carriers. D is the thalassemia patient. So answers A, B, C, D. Answer is D. Is that okay, student? So then the 10th question, again related to this. If we look at the 10th question, the ratio among the thalassemia patients, healthy disease carriers and healthy individuals. So there you need to find the ratio between thalassemia patients, healthy disease carriers and healthy individuals. Now you can remember earlier I wrote it in the previous slide. So capital T, then both of them were capital T, simple T. This is simple T, simple T. Initially you need thalassemia patients. Patients, there is one. TT, simple T, one patient. Then healthy disease carriers, that is this, capital T, simple T. That there are two. And finally, it is the healthy individuals, capital T, capital T. So that is also one. One disease, two carriers, and again one healthy individual. So the ratio is going to be 1:2:1. Answers 1:1:1, 1:1:2, 1:2:1, and 2:1:1. Students, now when we did this finding the F1 generations, occurrence of F1 generation, we were used to the Mendel's, the ratio. Now you can remember 3:1 phenotypic ratio, 1:2:1 genotypic ratio. But here you have to remember, students, there are some instances where you have combined genes or linked genes. Sex-linked genes, those diseases, the ratio will vary. And here also, these are mutated genes. When we write the ratio, you have to look at this particular order. That is very important. Here they have asked thalassemia patients first, then healthy disease carriers and healthy individuals. Now in this, we have the healthy individual, carrier and disease. Now here of course the order becomes reverse, but still we get the same ratio 1:2:1. But if they put these in a different order, then the ratio can change. For example, if they say carriers first, then disease and healthy people, then of course you will get the ratio as 2:1:1. So you have to look at this, what they have specified for the ratio. Then you can see according to this it is 1:2:1. So you are familiar with that ratio 1:2:1, but still you have to look at these specifications as well. Is that clear? So then I'll move on to the next question. Question number 11. Which statement is always true about the magnitude of displacement of a certain object? So under that you can see they have said displacement, always true about magnitude of displacement, but they have mentioned about the distance also. So first we'll just try to recall what distance and displacement are. Now for this I have put this example here, you can see. Now this is a diagram. You can see several paths between points A to B. So here you have point A, here we have point B. So you can see the distance, the arrow is marked towards the east. So that means the person or the object is moving from A to B. And there are different paths. Now here you can see path P, distance 320. Path Q, distance 200 meters. Then path R, distance 240 meters. And from A to B, that is the direct straight line path, that says distance 160 meters. So if object P travels path P, that will travel a distance of 320 meters. If it is path Q, 200 meters. If it is path R, 240 meters. So the distance will depend on the path taken. But the initial position is A, final position is B. So any person or an object traveling from A to B, depending on the path they take, the distance will vary. But what is the displacement? Displacement is the change in position from A to B when the object travels from position A to position B. That is the change in position. The shortest distance will be the magnitude of the displacement. So here the displacement is going to be this. Displacement, that is the displacement. Displacement. You need the initial position, final position, the straight line distance or the shortest distance in a straight line is going to be the magnitude of the displacement. And displacement has a direction as well. So it is from A to B. So it has a magnitude and the direction A to B. But when you compare all the distances, this is the shortest one. 320, 200, 160, 240. So this is the shortest distance. If the object traverses through this path, which has a distance of 160 meters, then the distance and the displacement will be equal in magnitude. But the displacement will be in the direction A to B. But if the object travels in the other paths, takes the other paths, the distance will be more, displacement will be the shortest one. Is that clear? So the distance can either be equal to the displacement or the distance will be greater than the displacement. Or else, in other words, you can say the displacement can be equal to distance or the displacement can be shorter than the distance. Is that clear? So, as long as you understand the concept, distance is the length of the path traversed by the object or person, and displacement is the change in position of an object or a person, but the magnitude is equal to the shortest distance between the 2 points. Is that clear? So, based on that only you need to answer the question. So, there. You can see here which statement is always true. So, here you have to see always true about the magnitude of displacement of a certain object. Greater than the distance moved? No. It can be either equal or less than the distance moved. Equal to the distance moved, that is also correct at certain instances. Lesser than the distance moved, that is also correct under certain instances. Either equal or less than the distance moved. That is the most suitable. Now can you all see, students? Out of all 4, 2, 3 and 4 are correct. But out of those 3, this is the most appropriate answer. So when you are answering the question, don't just read the second one and mark it. Read all the answers. Then only you will get the most appropriate. Because both second and third are correct, but only under certain instances. The fourth one gives you the complete answer. So here the answer is either equal to or less than the distance moved. Is that clear? It can be equal or less than. So that is why I showed you all this diagram as well. You can see here. It is either equal or less than the other distances. Is that clear, student? So with that, I'll move on to the next question. Question number 12. The electronic configurations of the atoms of 2 elements X and Y are 281 and 287 respectively. Of the following statements about the pair of those elements, which statement is false? So here they are asking for the false statement. Now look at the statements. Located in the same period in the periodic table, located in the same group in the periodic table, chemically combine forming ionic bonds, and combine and form the compound with the chemical formula X, Y. So to answer this question, I'll move on to the next slide. Now I have put the periodic table here. So you can remember, students, X, 2, 8, 1. I'll check the question again. X is 281, Y is 287. 281 and Y is 287. Now you all know there is a relationship between the electronic configuration and the position of the element in the periodic table. So if you take X, 281 means you look at the last shell, valence shell, the number of electrons equals the group number. So this has to go to group 1. Then the number of shells having electrons is the period. So this is going to be period. What is the period? There are 3 shells, so period 3. So here group 1 is the first one, period 3 is this one, so X will go there. Then Y, 287. Now this is 7, so group 7. Always when you write group number, it has to be in Roman letters. So here it has to be group 7. Then you can see again 3 shells have electrons. 3 energy levels contain electrons. So it has to be again period 3. So here Y has to go to period 3, group 7. You all know 1, 2, 3, 4, 5, 6, 7. So now you can easily see. You don't have to always draw this periodic table, but for your understanding, better understanding, I have done that. So you can see they both belong to the same period, but they belong to different groups. Now you can remember, students, the valency of elements. How do we write the valency? You can remember valency. How does it go? When it is group 1, 1, 2, 3, 4, then it goes as 3, 2, 1, 0. 0 valency for noble gases, that is group 8. So both group 1 has valency 1 and group 7 also valency 1. But you all know chlorine can have a valency of 7 as well. So this is again, you all can see it is group 7 and it can have a valency of 7, this particular Y, but they both show valency 1. Is that clear? Then you all can remember, students, group 1, it is a metal. Now group 1 is a metal. So this is a metal. Normally metals form positive ions or cations, X plus ions. Whereas Y, you can see it is a non-metal. That also you can see from the position. Group 7 usually non-metals. Fluorine, chlorine, you can remember non-metals. So non-metals usually form negative ion or cation. Now metal, here you can see X, you can see from the position. Hydrogen, lithium, sodium. Sodium usually forms positive ion, X plus ion. Non-metal forms Y minus negative ions. So when they form the bond, how do they form the bond? They can form the bond as X, Y. Valency is 1, 1. If you exchange a valency, you get the chemical formula as X, Y. And it is an ionic compound. Now I am sure you all have got the good understanding. So from the electronic configuration, you can find the position of the elements in the periodic table. It's not a must to draw the periodic table, but this gives a better understanding. Then we have found the position X group 1, Y group 7. Then to find the valency, you can see X has a valency of 1 and Y has a valency of 1 and 7, but there we take the valency as 1. So both of them have valency 1 and they form ions, metal X plus, and non-metal Y minus. And when they combine, they form an ionic bond, ionic compound. Ionic compound X, Y. Always we write the metal first and then the non-metal. And also you can see they both belong to the same period but different groups. Now we can answer the question. Look at the question now. The electronic configuration of the atoms of two elements X and Y are 281 and 287 respectively. Of the following statements about the pair of those elements, which statement is false? So then you can see, located in the same period in the periodic table, yes, they were both in period 3. Located in the same group in the periodic table, no. X is group 1, Y is group 7. Chemically combined, forming ionic bonds, that is also correct. X plus, Y minus. Combine and form the compound with the chemical formula X, Y, that is also correct. So the false statement is the second one. Located in the same group in the periodic table, that is false. Is that clear now? So then I'll move on to the next one. Question 30. What is the number of O2 molecules contained in 64 grams of oxygen gas? So here students, you all have to remember, we take the molar mass. What is molar mass? You need to find the relative molecular mass or the relative atomic mass, that with the unit grams per mole. Here you can see O2 means, what is the mass? Oxygen is 16, so 2 times 16, you get it as 32. That is the relative molecular mass. For the relative molecular mass, if you write it with the unit 32 grams per mole, then you know it is the molar mass. That means 1 mole of substance, the mass is 32 grams. So if you take 1 mole of oxygen gas, the mass is 32 grams. But here they have said 64 grams of oxygen. What is the number of moles there? So if you find the moles of O2, you can see 64 grams divided by 32 grams per mole. So you can see 2 moles. Now 64 divided by 32, the answer is 2 moles. Then you know students, in 1 mole, how many particles are there? Avogadro number of particles. Normally when we say Avogadro constant, if you take the molar mass of substance or relative molecular mass of substance in grams, exactly the relative molecular mass of substance in grams, and if you count the constituent particles, there will be 6.022 into 10 to the power of 23 particles. That is what we call as Avogadro constant. So there, you will see in 1 mole of O2, there are 6.022 into 10 to the power of 23 molecules. So in 2 moles, how many? 2 into 6.022 into 10 to the power of 23 molecules. So this is the number of oxygen molecules in 64 grams of oxygen. Is that clear? Here students, I have calculated the number of moles and then I have found the number of constituent particles or the oxygen molecules. If you want, if you are clear with the concept, you can do these 2 steps together also. How do we do that? I will show you all. So there, 1 mole of O2 is equal to 32 grams of O2. That is equal to 6.022 into 10 to the power of 23 O2 molecules. Is this okay? 1 mole means 32 grams of oxygen gas, and that has Avogadro number of oxygen molecules, what we understood before. So therefore, in 64 grams of O2, what we can say is in 34 grams, there are 6.022 into 10 to the power of 23 molecules. Therefore, in 64 grams. Like this also, you can write and simplify. Still, you will get the same answer, 2 into 6.022 into 10 to the power of 23 molecules. So, if you all are used to the first method, you can do it that way. Find the number of moles, then find the number of molecules. Or else you can combine and write this equation and find the number of molecules. Either way, you will get the same answer. Now, if we go back to the question, here you can see what is the number of oxygen molecules contained in 64 grams of oxygen gas. First one, O, they have given as 16, and the first answer 6.022 into 10 to the power of 23, that is Avogadro constant. 2 into 6.022 into 10 to the power of 23, that is correct. 4 into 6.022 into 10 to the power of 23, no. And 64 into 6.022 into 10 to the power of 23, that is also incorrect. The correct answer is the second one. This will become the answer if they ask you to find the number of oxygen atoms. Now you all know, students, in one molecule of oxygen O2, you can see there are 2 atoms. So in 64 grams of oxygen gas, there are 2 moles of oxygen molecules, but there are 4 moles of oxygen atoms. That is why they have given this answer. And here, of course, directly they have multiplied by the mass. So that is how they give answers. The answers are also related to the concept in some way or the other. You have to select the most appropriate answer. Is that correct? Here, of course, it is the correct answer, 2 into 6.022 into 10 to the power of 23. With that, students, I'll move on to the next one. Question number 14. W, X, Y and Z are 4 elements consecutively placed in the periodic table with atomic numbers below 20. So, it is between hydrogen and calcium, the first 20 elements in the periodic table. The graph indicates how their first ionization energy, that is I1, varies against the atomic number. In which group of the periodic table is Y placed? So here you can see, students, the graph given to you. Y-axis, I1 is the first ionization energy. The unit is given as kilojoules per mole. And here you can see x-axis is atomic number. So there you can see W, X, Y and Z. So as you look at the first ionization energy graph, you have to relate it to the graph that you have learned and identify the positions, the group numbers. Here you can't say which is the atomic number, but you can identify the group because they have period 1, period 2, period 3 and period 4. So from that you can easily identify the group. Now look at the answers, group 1, group 2, group 3, group 4. Now we'll try to understand the graph in the next slide. Now here, this is the complete graph. I have put that here. What do you see? Again, first ionization energy, kilojoules per mole and atomic number. Now this part, students, you all can see here, always group 1 is the first element, then group 8. Again, there is a drop, lithium. So this is group 1, lithium group 1, sodium group 1 and potassium group 1. The same way you can see here. Now helium group 8, neon group 8, argon group 8. Always in each period, group 1 has the lowest first ionization energy, group 8 has the highest first ionization energy. You all know across the period from left to right, the first ionization energy increases according to a pattern. So here there is an increase. Here you can see the zigzag pattern, but still it increases. First, second period, then the third period. Sodium to argon also, there is an increase in a certain manner. Again from potassium, if you look at the fourth period also, there will be an increase. So always group 1 has the lowest first ionization energy, group 8 has the highest first ionization energy. Then what do you see here? Now in this one, when it goes from group 8 to group 1 of the next period, you can see there is a sudden drop, a drastic drop that can be identified easily. Again here, there is another sudden drop. From here to here also, you can see there is a sudden drop. So always from group 8 of the top period to the next period, group 1, there is a drop. 1 to 2, 2 to 3, 3 to 4. So from one period to the other, group 8 to group 1, there is a drop. Those are the patterns you can identify. And also you can see here a zigzag pattern. Lithium group 2 up, group 3 down, 4, 5, then 6, 7, 8. A zigzag pattern can be observed. So then, using that, you can see this zigzag pattern also. Group 1, 2, then 3, then 4, 5, then 6, 7, 8. Like that also you can see the gradual change. So these are the information you need to look for in a graph. Then you can easily identify the group number. Is that clear? So this is the first ionization energy of the first 20 elements. Now if we go to the question, can you all identify? What do you see? W to X, there is a drastic drop. Then X to Y increases, again Z slightly less. So what can you see? This has to be group 8 of one period. Then X has to be in the group 1 of the next period. So this has to be group 1. So Y will be group 2 and Z will be group 3. Is that okay? So we use this drop to identify the elements. If this was in the first period, this would be the second period. If this is the second, this would be the third period. Like that, you can identify the elements also depending on the answers given. But here, they have asked the group. In which group of the periodic table is Y placed? So that is, you can see group 2. The answer is group 2. Is that clear? So then, the next question, question 15. The substances acting as the main components providing energy for the functioning of the human body are. So they have given proteins and lipids. Now you all know, students, when we take the energy sources, there are biomolecules, carbohydrates, proteins, lipids and nucleic acids. Now nucleic acids, of course, they do not provide energy because they either store genetic information or protein synthesis. Those are the functions. But the other three, carbohydrate, proteins and lipids, they all act as energy sources. But you all know, carbohydrates and lipids are the main energy sources. If there are no carbohydrate or lipid source in the human body, then protein acts as the energy source. In the absence or not enough carbohydrates and lipids, then protein acts as the energy source. So the main energy sources are carbohydrates and lipid. And another thing you have to remember, lipids provide more energy compared to carbohydrates. That is how the biomolecules are. But the main energy sources are carbohydrates and lipids. So if you look at the answers, you can see proteins and lipids, proteins and vitamins. Vitamins, what are vitamins? They are again organic compounds, but they don't provide energy. They are vital for the biochemical reactions. For example, clotting of blood or other reactions. So they are important for the biochemical reactions. Then carbohydrates and lipids. Like I said, they are the main energy sources. Carbohydrates and proteins, no. Protein is the third level. So maximum energy is provided by lipids, then carbohydrates. But both carbohydrates and lipids are the main energy sources. In the absence of carbohydrates and lipids only, proteins acts as the energy source. So the answer is carbohydrates and lipids. Is that clear, students? So then, students, you all know the answer for the 15th question. That is the third answer, carbohydrates and lipids. So with that, I am going to end this chapter here, and in the next chapter, I will continue with the rest of the MCQ questions in the 2020 O-Level Paper 1.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.